This lesson is called Combining Like Terms. Let's write our date on the paper, the top left. Please copy down this expression. I just want to quickly review what terms are. We learned that terms are smaller parts of a larger expression. So this whole thing here, 35 divided by 7 plus 3y minus 4 times 9 minus 2, that whole thing is an expression. But there are smaller parts called terms. And you may recall that terms are separated from each other. How are they separated? Well, just like walls separate classrooms, terms are separated by what you might call walls, which are plus and minus signs, or adding and subtracting signs. So this addition sign is a wall that separates terms, and there's a subtraction sign that separates terms. So we could circle the terms to show how they're separated, or show how they're kind of each individual parts. So for example, in this expression, we circle and we don't stop at the division because division doesn't separate terms, it stays inside. And then we stop here. Here's a wall right here, so we stop there. So one term, the first term in this expression is 35 divided by 7, but then there's a separator, and we start the next term. 3 times y, that's a term, but then we have to stop because there's a minus sign. That's a wall that separates. So 3y is the next term, and then 4 times 9 is another term, but then there's a wall there. And so finally, after this separator, we have the 2. So in this case, we had 4 terms inside this expression. But today we're going to be talking about something called like terms. That means terms that are in some way like each other, and we have to know what that means exactly so that we can combine those terms that are like each other. Take some time to copy down these explanations here, these definitions about like terms and unlike terms. If you need to pause the video to copy that down, go ahead and do that, and then start again when you're ready. It says like terms are considered to be like each other if they, I should say here, if they have both. Sorry, it should say if they have both. So they have to have both of these things, the same variable and the same exponent. And unlike terms are different from each other in these characteristics, in terms of variables and exponents. So let me show you what I mean by that. We're going to have a category of like terms, and then we'll have a category of unlike on this side. Unlike terms. An example of like terms would be if we were trying to add together 4w plus 7w, we would say this term 4w is like this term 7w because it meets these characteristics, it meets these requirements. Because remember, like terms are considered to be like each other if they have both. So they're like each other if they have both of these things. They have to be the same variable, they have to have the same variable, and they have to have the same exponent. So when we look at 4w, the variable is w, and we look at 7w, the variable is w. They have the same variable, and they also have the same exponent, which means in this case we don't see an exponent. We don't see a little number up on the shoulder. So that means they just don't have that. And they're like each other in that way. But if we saw this, if we had, let's say, 3c plus 9x, we would say those are unlike terms, because in this case we're looking to see if they have the same variable. They don't. This one has a c, and that term right there has an x. So these are unlike terms. They're not like each other. Another example would be, well, just numbers. You could have 15 plus -2. Those are like each other. And the reason they are is because we're looking for the same variable. Well, 15 doesn't have a variable and -2 doesn't have a variable. They just have no variable, but that means they're the same because they just have no variable. And also exponent. Do they have the same exponent? Yeah, in this case they don't have one, so it's the same in that category as well. But if you were to take the example 17r plus -5, in this case they're unlike terms. They're not like each other because we're looking at whether they have the same variable. The 17r has the variable r, but the -5 doesn't have a variable, so they're not like each other. These are considered unlike terms, which means we cannot add them together. And that's what we're going to talk about next. And we're going to talk about combining or adding terms together. Let me give you one more example. If I've got a 7x plus, 7x to the second power plus x to the second power. These are considered to be like terms because we've got the same variable. They both have the x and the same exponent. They both have a little 2 exponent on them. So because they have both the same variable and the same exponent, we can say these are like terms. Notice there's one of them has a number in front. There's a coefficient on this one, and this one doesn't have a number in front. That's okay, because that's not important for determining like terms. The only thing that's important for like terms is they have to have the same variable and the same exponent. So we can say, yes, these are like each other. But if we were to have 5m to the third power plus m to the second power, these would be considered unlike terms because they both have the m, which is good, but this one has the exponent 3 and this term has the exponent 2, and that doesn't fit the requirement because the requirement says they have to have both the same variable and the same exponent, but these two terms don't. So all of these examples are examples of unlike terms. They're not like each other. And all of these examples over here are examples of like terms. We could say, yeah, these terms are like each other because they fit the requirements that are shown above. Now we get to the point in our lesson where we're going to actually combine terms. Combining the terms. Now that we know what like terms are, when we see like terms, we can add them together. Or we could also subtract them if there's subtraction as well. So let's look at this expression. We've got 4m plus 7 plus 2m. So we can see there are 3 terms. 1, 2, 3 terms, all separated by plus signs. There are 2 terms that are like each other. The 4m and the 2m are like each other because they both have the same letter, same variable, and the same exponent. In this case, there's no exponent. And the rules tell us, when we're talking about combining like terms, the rules tell us that we can add them together or subtract them. In this case, there's addition. So we can say 4m cannot add with the 7 because the 7 doesn't have an m, but it can add with the 2m. So we could rearrange. We could say 4m, and we'll take this plus 2m, put it there, and then this plus 7. We can add these 4m, the 4m with the 2m. The way we do that is we just add the number in front, the coefficient. So the 4 plus the 2 is 6. So instead of 4m separate from 2m, we now have 6m altogether. And we have a plus 7. And that's all we can do because we can't add a 6m with a 7 that has no letter at all. These are not like each other. These are unlike terms. So we just leave it, the answer, there like it is. Another example, example B, let's say we have 9x plus 10x squared minus 3x squared. Again, we've got three terms here. I'll circle my terms in red. 9x is a term, but then we have the plus sign that separates terms. 10x squared is a term, and then minus 3x squared. Do we have any like terms here? Yes, we do. Like terms have to have the same letter and also the same exponent. All of these have x. There's an x here, an x here, an x here, but only the last two have the x to the second power. The little exponent is the same on these. So these are like terms, whereas the first one is not like the other ones. So the first one's going to stand alone, 9x. We can't do anything to combine that, but we can combine 10x squared minus 3x squared. Notice it's a minus sign, so we're not adding, we're subtracting. What we do is we take the coefficients, the numbers in front, and we subtract. 10 minus 3 is 7. So 10 minus 3 is positive 7, so that means we need a positive, or we need to keep our add sign there. It's a positive 7x squared that we have. And that's all we can do, because this term and this term are not like each other, so we cannot add them together. We just leave it like it is. Here's our last example. 5n minus 12 plus 5y plus 15. So you might want to try this one on your own. You can stop the video, identify the terms, and try to combine the like terms together. See if you can do that on your own, then start up the video again when you're done. There is the potential to get confused a little bit on a problem like this, or an expression like this. We can see there are four terms. 1, 2, 3, 4. And sometimes students get confused. They look at something like 5n and 5y, and they think because they both have a 5 in front that you should be able to add them together. But actually, that's not what we should be looking for, because remember, we learned earlier that like terms are considered to be like each other if they have both the same variable and the same exponent. So let's look and see if these have the same variable. 5n and 5y have a different variable. So these are not like each other. We can't add those together. What can we add together? Oh, there's a 12, that's a number, and a 15, that's a number. They don't have any variable and no exponent. That means they are the same. So these are like terms that we can add together. But be careful, because we always have to look at the sign in front of the number. So this 12 has a minus in front. That makes that a negative 12. It's a minus 12, a negative 12. So we could just write the 5 in first. That's not going to combine with anything. We could write the 5y next if we want, plus 5y. But now we need to combine these two terms, the minus 12 and the positive 15. What's negative 12 plus 15? You might remember when we are adding a positive and a negative together, we're going to get 0 pairs. But are we going to have more positives left over in the end, or more negatives left over when we get 0 pairs here? Well, there's more positives. There's 15 positives and only 12 negatives. So we can just do 15 minus 12, which is 3. And then we could say, well, there's going to be leftover positives, so it's got to be positive 3. So we combine these together and we get a plus 3. And then we're done, because none of these are like terms now. These are all unlike terms. So we just leave it as is. And that's our final answer.